Hello everyone, welcome to Mathematics Foundation classes. Today I will teach you inverse trigonometric functions. This very important chapter in mathematics. Before I begin the inverse trigonometric functions, I will just have a quick review of the portions we studied in chapter 1. There is functions, type of functions there, which is very important. Okay, let us get started. Now, function is a relation from one set to another with the two conditions. Every element in the first set has image in B and no element has more than one image in B. And the type of functions, we have one functions. One functions, each element has its own image there. For every element of the first set, for every element of the domain set has one image in B, only one image in B. Now look at the first example here, one function. So f is a function from A to B. We have A, B, C are the elements in the domain set, and 1, 2, 3, 4 are the elements in the codomain set. Now A has the image 1 and B has the image 2 and C also has the image 3. C has the image 3 and the number 4 doesn't have any image. Now look at this first function here from A to B. All the elements in the domain set have images and therefore it is a 1 function. A has its own image 1, B has the image 2 and C has the image 3. Therefore it is a 1 function. And look at the second, which is not 1. If the function is not 1, then it will be many one functions. So look at the second example here. F is a function from A to B and A has image 1 in B in the codomain and B has image 2 and look here now C has image 2, which means B and C share the same image, therefore it is many one because many two elements share, therefore it is called many one, so it cannot be 1 function. If a function is not 1, definitely it will be many one functions. Now let's go to the third example, that is 1 and also on 2. So 1, why the function is 1? Because you know that each element in the domain, you can see its own image. A has 1, B has 2 and C has 3. So all the elements have its own images, therefore it is 1. And no element in B is left on 2. Actually, what is the definition of on 2 function? The elements of B has its own, for every element in this Y has pre-image in the set A. Now you can see no element is left in the codomain without a partner in A. Therefore, we can say this is an on-to function, all the elements. So it is a 1 on-to. Okay, now see the fourth example here. That is a many one and on-to function. It is many one because you see that in the domain set A has image 1, B and C share the same image. Therefore, it is many one, but it is on-to because all the elements of the codomain are the images of some elements of the domain set. So look at the 4 examples now here. 1 function, but it is not on-to. Why it is not on-to? Because the element 4 is not used here. The 4 doesn't have a pre-image in the domain, and 4 is not an image of any element of A. Okay, therefore it is not 1, therefore it is into function. Okay, then number 2, many one function, and in the many one function again it is also into function because it is not onto. The 3 doesn't have any pre-image in the domain set, or we can say that the 3 is not the image of any element of the domain set. Therefore, it is also into, not onto. Okay. And the third one is of course 1 and onto. All the elements of the domain set have its own image, and no element is left without a partner of the domain set. Therefore, it is 1 and onto. And again many one and onto here. Okay, now here as per the definitions, in order to have an inverse function, okay, in order to have an inverse function, the function must be 1, 1 and on 2. Why such a condition? Actually, always we discuss that because the first function 1, 1 and into 1, 1 and into. So if you find out the inverse, actually, how do we find out the inverse function? We just switch the domain and codomain. Therefore, in order to find out the inverse function, the function domain will be the domain B will be the domain of the function f, and the domain function of f a will become the codomain here. Once again, in the function a to b, a is the domain and b is the codomain. But in the inverse function, just to switch that, b will come to the domain set and a will come to the codomain set. So it is an inverse function. The inverse function is from B to A. So all the elements 1, 2, 3, 4 in the codomain. Look at here, all the elements of the codomain and elements of the domain A, B, C. Now which is that 1, actually 1 will be connected to A, okay, 1 will be connected to A, and 2 is connected to B, and 3 is connected to C. Now look here, 4 doesn't have an image, and as per the definition, it is clearly given that in order to become a function, the relation become a function only when all the elements in the domain have images in B. All the elements, there is a condition. So the definition of a function, there are two conditions. First condition is that all the elements in the domain will have image in B, and no element in the set has more than one image. So this is not a function. Therefore, we cannot find an inverse function from the 1, 1 into. Okay, now look at the second example here. In the same way, if you switch that, if you switch the domain and codomain, so B comes here as a domain, A, the domain will come to the codomain. So F inverse from B to A, so 1, 2, 3, the elements of codomain become now elements of the domain, and the elements of domain A, B, C are the elements of the range. Then the connections here, 1 and A, 1 is connected to A, the image of 1 is A, and 2 and B, and 3 and C. Now look here, no, 3 and 3 actually, 2 now and C, 2, the image of 2, look here, B and C. This is also against the definition of the function. Actually, the definition of the function, a relation will become a function only when the elements of A has only one and only one image. The elements of A, the elements in the domain set has only one image. Now look at here, A has only one image, B, the elements have two images. That is not allowed. So it is only a relation, it is not a function here. So this is not a function. Therefore, we cannot find out an inverse function here. Now look at the third example here, 1, 1 and on 2. When you find out the inverse function, we switch the A and B. Therefore, the codomain B becomes the domain here, and the domain A becomes the codomain here. So the inverse function will be a function from B to A. The inverse function from B to A. Therefore, we know that the domains, the domain set A, B, C are the elements in the codomain. Okay, if you switch it, and the elements in the codomain 1, 2, 3 are the elements in the domain set. Therefore, we see A is connected to 1. Therefore, 1 is connected to A. 2 and B are connected. 3 and C are connected. Okay, this is 1, 1. At the same time, it is on 2, and clearly it is very clear that the condition of function is satisfied here. Whereas these two cases, these two are not functions, but the third one is clearly a function. Therefore, in this case, we can find out inverse function for B to A. The same way, you know that here inverse function of the minimum onto function, if you switch the domain and codomain, the codomain B will become the domain here, and the domain A will become the codomain here. So the F inverse is a function from B to A. and the 1, 2 elements of codomain. Now we will switch into the domains, and A, B, C of the elements we switch to the codomain. So one is related to A and B and C. B and C. 2 is connected to B and 2 is connected to C. So this is also against the condition for the function, because the definition of the function says that element from 1 to, sorry, a relation from A to B is said to be a function if all the elements have images and no element is having more than one image. Here you can see 2 is having the element 2 is having 2 images, which is not allowed here. Therefore this is also not possible here. And I think you remember that in the first chapter we learned the inverse function exists only if the given function is 1, 1 and 1, 2. Okay, if the function is 1, 1 and 1, 2, then only the inverse function exists there. That's very important point, because you know that the inverse trigonometric functions, the chapter itself is very important here. To learn the calculus, we want to know that, and to find out the values of the trigonometric functions is very important here. Therefore, please remember this point, that the function will have an inverse function only when the function is 1, 1 and 1, 2. And what is 1, 1 and 1, 2? 1, 1 is that all the elements of the domain sets have same images, only one image, and no element is having more than one image. Okay, that's not a function there. Then no 1, 2 is no element here is left without a pre-image in A. So this is what 1, 1 and 1, 2. And I'm going to give you the example of a function and how to find out an inverse function from the given function. That's also very important here. So how to convert a function into its inverse function, that's very important here. So with a simple example I will show here. Now example 1, we have here a function f from x to y. So x is the domain set and y the codomain set here. Okay, and small x represent the element of x and small y represent the elements in the y in the codomain here. Now the relation 1, the element 1 is connected to 4, and the 2 is connected to 5, and 3 is connected to 6, and 4 is connected to 7. Now look here and establish a relation and form a relation between x and y. Now look at the examples in the codomain, the elements in codomain 4, which is 3 greater than x, and 5, the elements in the codomain is 3 greater than 2, and again the element 6 is 3 greater than 3. So from here we can establish the relation, that is the elements y, actually y is equal to the elements x plus 3, which is from the domain add 3, you will get the range here. 1 plus 3 4, 2 plus 3 5, 3 plus 3 is 6, and 4 plus 3 is 7. Therefore the function here is y equal to x plus 3 or fx equal to x plus 3, because x plus y and fx are same. Okay, the function of x here is fx equal to x plus 3, y equal to x plus 3. So this is the function here, fx. Now look at the function once again. You will come to know that the function is 1, 1 and 1, 2. All the elements, look at here, is one image you will find here. Look at the domain elements and look at the range elements. In the range elements 4, okay, is connected to 1. 4 is the image of 1, 5 is the image of 2, 6 is the image of 3, 7 is the image of 4, and all elements in the range are increased by 3 here. Therefore, the domain elements are 1, 2, 3, 4. 1, 2, 3, 4 are the domain elements, and the range here 4, 5, 6, 7. 4, 5, 6, 7. So, what is now f inverse, the inverse function, and how can we find out the inverse function here? That is the thing actually. So, in the inverse function, we know we switch the codomain into domain and domain to codomain. So just interchange. So y will become the domain here and x will be the range here. So y actually 4, 5, 6, 7. 4, 5, 6, 7 are the elements in the codomain. Okay, and the range 1, 2, 3, 4. Look here, the elements of codomain and elements of range, we have the switch each other, we interchange each other, therefore 4 to 1 now, and 5 connected to 2, 6 is connected to 3, and 7 is connected to 4. Now establish the relation. What is the equation or what is the relation in the inverse function? Now you know that 4, which how can reach 1 decrease by 3, 5 minus 3, 6 minus 3, 7 minus 3. Therefore, now here codomain is x, therefore x equal to y minus 3. X equal to y minus 3. X represent the codomain, the elements in the codomain, y represent the elements in the domain. So x equal to y minus 3. This is the relation. So to find out the relation or to form the function, I think you don't have to find out from the elements itself, because this is the inverse function is the function of fx here, and fx is y equal to x plus 3. You know, y equal to x plus 3, where x represents the domain elements and y represents the range elements here. When we switch, actually just interchange that, x will be x represent the codomain, so range elements in the f inverse, and y represent the domain. Therefore here we need to find out what is x here. X is equal to, take y to other side, y minus 3. So in this way, from the function itself you can find out x, therefore x is y minus 3. Same thing we are getting that. You don't have to find out from element to element connections. From the function itself we can find out the equation. Therefore f inverse x, f inverse not x actually, f inverse y equal to y minus 3, or x is equal to y minus 3. Therefore f inverse of y equal to y minus 3. This is the inverse function, and you know, this is again you can see it, because the function is one word and onto, that is why we got the. Look at the second example. The given function is fx equal to 3x plus 2. It is a function from x to y, and x is the domain set and y is the codomain set. Now it is connected 1 to 5 with the relation fx is equal to 3x plus 2. So 3x plus 2, when x is equal to 1, 3 times of 1 plus 2 is 5. x2, then 3 times 2 plus 2, that is 8. 2 is connected to 8, and 3 is 11, and 4 is connected to 14. So 1, 2, 3, 4 are the elements in the domain, and 5, 8, 11, 14 are the elements in the range. Now since the function is 1, 1, okay, it is 1, 1, and also it is on 2, therefore this function will have an inverse function. Now how can you find out the inverse function? You can do two ways. Either you establish a relation from after switching the two sets y and x, okay, the y will become the the codomain will become the domain here, and the domain will become the codomain here, x. So the f inverse is a relation from y to x. This is f inverse. Then to establish that, I think it's better if we form from here. So y is equal to 3x plus 2, and find out x from here. Therefore you take y2 to the other side, y minus 2 is equal to 3x. Therefore x is equal to 3x equal to y minus 2. So x is y minus 2 divided by 3. Therefore the f inverse of y is y minus 2 divided by 3. And the first elements, okay, now interchange the elements here. The elements in 5, 8, 11, 14. So if you take y is equal to 5, 5 minus 2, that is 3, divided by 3, that is okay, 1. Same way, you are getting 1 here. And when x equal to 8, the value 8, y minus 2, 8 minus 2, 6, 6 upon 3, that is 2, okay. Then y is equal to 11 here. 11 minus 2, 9 divided by 3, that is 3. And 14 minus 2, 12, 12 divided by 3 is 4. So 5 is connected to 1, 8 is connected to 2, 11 is connected to 3, and 14 is connected to 4. This is the inverse function f inverse y equal to y minus 2 divided by 3, or we can say x is equal to y minus 2 divided by 3. This is the inverse function. Now I think it is clear how to make an inverse function. So what is an inverse function? The condition is that the given function must be 1, 1 and 1, 2. Okay. Now let us now move into the trigonometric functions. We shall move into the trigonometric functions here. Trigonometric functions are very important here, therefore you should listen carefully. Now let's get started here. In the trigonometric function, from a function from x to y, where x in the domain elements represent the angles here, and in the range that also the values of the angles here. So for example, I have shown the function y equal to sine x here. This function in the domain you can take any real number. Whatever the value you give doesn't matter. Any real number can be the elements in the domain. The same way, any real number can be the elements in the range. Now look at the values here. Sine 0, okay, sine 0 is 0, okay, and sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. I have given only few examples here. As I have already told you that the elements in the domain can be any real number that. And also remember that 0, sine 0 is 0, and normally in the angles we represent the radian, therefore pi 30 degree which is equal to pi by 6, and 45 degree which is pi by 4, and 60 degrees that is pi by 3, and 90 degrees pi by 2. So because you know that this is measured in degrees and this is measured in radians. Okay. Then one more thing here I want to, this is a graphical representation of the functions sine x here, and the values we start from 0 degree, okay, 0 degree, sine 0 is 0, then sine 90, that is sine pi by 2 is 1, okay, sine pi by 2 is 1, then sine pi, that is 180 degrees, 0 again, okay, this is one important thing. Look here, sine 0 is 0, again sine pi which is also 0. Okay, look here, again sine 2 pi which the function again becomes 0. Therefore, sine pi, sine 0, sine 2 pi, sine negative pi, sine negative 2 pi, all these values are 0. Which means, what do you understand from here? What do you understand from here? This function is a many-one function. So if the function is a many-one function, you cannot find an inverse function because many-one functions will not have an inverse functions here. Therefore, we need to restrict the domain. Otherwise, we cannot find out the inverse function here. And if you find out the inverse function, you know the range will become the domain, and the domain will become the range here. So again, what are the values of the range here? Now the range, the values are between -1 and +1. The sine function, the values will come only between +1 and -1. Therefore, the range will be only between -1 less than or equal to y less than or equal to x, or closed interval of -1 and +1. This is the range of the sine function. And codomain. So this is a codomain, and the domain values actually, you know that we need to restrict that. So I will show you that how to restrict the domain in order to have a inverse function. Look at the example here. The function f from x to y, where x is the domain. The domains, the angles given in radians, and the range which is the values of the sine function here. Sine 0 is 0, sine pi by 6, that is 30 degrees 1 by 2, sine pi by 4, which is 45 degrees 1 by root 2, sine pi by 3, which is 60 degrees root 3 by 2, and sine pi by 2 90 degrees 1 here. Therefore the elements in the domain, that is 0, pi by 6, pi by 4 and pi by 2. And the range of the elements 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. Now okay, these functions, what is the inverse function here? We switch the domain and codomain, so while the elements, the values of the sine function, this is the domain here 0, 1 by 2, 1 by root 2, 1 root 3 by 2 and 1, and the angles in radian, that it will be the codomain here. So the domain here is 0, 1 by 2, 1 by root 2, root 3 by 2 and 1, and the range is 0, the angles pi by 6, that is 60 degree, pi by 4, pi by 3, pi by 2. So this function from angle to the values of the sine, again from in the inverse function from values of the sine to the angles here, this is the inverse function. Now let us see the graph of the sine function. Look at the graph of the y equal to sine x function, and in the domain I have taken the values here. Look at the graph here. In the x-axis we have taken the angles in radians, and the y-axis we have taken the values. So this is the y-axis and this is the x-axis. Look at the graph here. The graph never go above positive 1. You can look at the, it did not go above the positive 1 and it minimum negative 1. So the graph is now moving between positive 1 and negative 1. So I have mentioned here negative 1 and positive 1 here. The maximum value of the sine function is positive 1 and minimum value is negative 1. Of course, it's a range from real number to negative 1 to positive 1. Okay, positive 1. This is the function. The real number we have taken here. But again, look at the values. Negative pi by 2. Negative pi by 2, that is negative 90. Negative pi by 2, the value is negative 1. And 3 pi by 2, that is 270 degree. Again, the value is minus 1. Therefore, negative pi by 2 and 3 pi by 2, the two is share the same value in the codomain here, the range. Therefore, it is a minimum function. Similarly, negative pi 0. Negative pi, the function is equal to 0. Y sine negative pi is equal to 0. Sine negative pi is equal to 0. Sine 0 is equal to 0. Sine pi is equal to 0. Sine 2 pi is equal to 0. Therefore, these are all values connected to 0. The image is 0 here. This is a clearly is a minimum function. Again, sine 90 is equal to 1. Again, sine 5 pi by 2 is 1. These are the only limited values I have given here, because in the x-axis, in the domain, we have infinite number of elements. Therefore, there will be infinite number of elements which give the same value negative 1. Infinite number of elements you will find in the domain which will give the same answer 0. Infinite number of elements in the domain which will have the same value 1. Therefore, this is minimum function. Can it be a function? You tell me, can it be a function? As per the definition of the inverse function, okay, of course, this is a minimum function. As per the definition of the inverse function, the function should be 1, 1, 1 and on 2. It is not 1, 1, it is a minimum function. It is a minimum function, therefore, there won't be any inverse function. Inverse function does not exist. You know why? Because the previous examples clearly I gave you the explanation here. Okay, let's see that in the inverse function. If you find the inverse function of the given function, what will happen here? We switch from the value negative 1, 0, 1 here, and the codomain will be the element from the domain here, that's the real numbers, and negative pi by 2, 3 pi by 2. I told you these are the only two values given there, but look at here, this y has infinite number of images. The negative one, the value has infinite number of elements if you find out the inverse function here, which is not possible. Here. And again 0. If you switch the domain and codomains, so negative pi, 0, pi, 2 pi. These are all images of the value 0. Similarly, the same way, pi by 2, 5 pi by 2. These are the images of 1. Therefore, this is not possible because as per the definition of the function, you know that the elements in the first set, the elements in the domain set should not have more than one image. You can see that one has infinite number of images, the element 0 has infinite number of images, the element 1 has infinite number of images. Therefore, it is not possible. Therefore, there will not be a function, inverse function here. So, what shall we do here? Okay, so in order to find out the inverse function, we need to restrict the domain here. So restrict, if you take the domain, the domain between minus pi by 2 to positive pi by 2. If you take the value between negative pi by 2 to positive pi by 2, okay, between negative pi by 2 to positive pi by 2, the domain value if you take, then we will not have more elements in the we will not have more elements here. Therefore, this is this is known as the principal value branch. The principal value branch. So that will be the range negative pi by 2, positive pi by 2. Therefore, negative 0, positive, between negative 1 and positive 1 will be the domain, and the range will be between negative pi by 2 to positive pi by 2. The value is between negative pi by 2 to positive. This will be the domain of sine function. Then only if you restrict the domain, here between negative pi by 2 to positive pi by 2, then we can find an inverse function. Okay, otherwise, if you don't take this range, we also can have between pi by 2 to 3 pi by 2, or we can take 3 pi by 2 to 5 pi by 2, or we can take minus pi by 2 to minus 3 pi by 2. So any of this range can be the domain of the y equal to sin x. Then that function will have an inverse function here. Therefore, it is very important to find out the principal value branch to find out the inverse function. Once again, I repeat the same thing here, because the y equal to sin x function is a minimum function, because we can see from the graph the value 0, the value negative pi, the value pi, 2 pi, all these values sine will have 0 there. Therefore, it is a minimum function. So, minimum functions will not have an inverse function. Therefore, we restrict the domain between negative pi by 2 to positive pi by 2. Then that function will have an inverse function. Therefore, this is called the principal value branch of the sine function. Sine function negative pi by 2 to positive pi by 2. Look at the table here. These are the values of the domain and range, and we have restricted the domain and domain values in order to get an inverse function here. So let us see that all the trigonometric functions you can find out in the table. Sin x, y is equal to sin x. The domain is the real numbers, all the real numbers, and range is between minus 1 to close interval between minus 1 to plus 1, which is negative 1 less than or equal to x less than or equal to 1 here. Less than or equal to y less than or equal to 1 here. Same way cos x, again domain can be the real numbers, and the range is negative 1 less than or equal to y less than or equal to 1. Then in case of tan x, the domain is real number minus 2n plus 1 into pi by 2. Those values are not possible here. From the real number, these points are restricted because these points, the graph goes to infinity. That is why to minus real number minus the values of multiples of 2n plus 1 into pi by 2. And again, the range is real numbers. Cot x again r minus n pi. R minus the real numbers minus n pi, and the range is the real numbers. Sec x r minus 2n plus 1 into pi by 2, and the range is r minus open interval 1 1, which is minus 1 less than y less than 1. And then cosec x is r minus n pi, which is the domain, and r minus close interval minus 1 minus 1 1, that is minus 1 less than y less than 1. So this will be the range. Now these are very important to know, the range and domain. These are the domain and range. Therefore it's very important to find out the domain and range. Okay, and here you know that this is the function. Normal cases this happens here, but in order to obtain the inverse function, we need to restrict the domain all from these cases that we shall discuss in the next part.